Hello and welcome back to Diksha Karnataka YouTube channel. So if you are following our channel, so far we have discussed KCET 2025 strategy, KCET 2025 book list. Also we have covered KCET 2025 syllabus. Now what we are going to do, we are going to discuss KCET 2024 paper, solved paper from question number 1 to 30 in this video. In the next part we will cover 31 to 60. Again, we will cover 2023 paper as well KCET 2022 paper. Okay, and if time permits, we will cover more papers. So stay tuned. If you have not yet subscribed to our channel and you are preparing for KCET 2025, don't forget to subscribe to our channel because we are going to cover each and every topic, each and every paper, each and every question related to KCET 2025 in our channel. So let's move on to the first question of KCET 2024. In Young's double slit experiment, an electron beam is used to produce an interference fringes of width beta 1. Now the electron beam is replaced by a beam of protons with the same experimental setup and same speed. The fringe width is obtained is beta 2. The correct relationship between beta 1 and beta 2. So we know that the beta is given by lambda capital D by small d. Okay, if you are wondering what are those symbols are, you can check in your textbook what all those symbols are, but there is a heads up, this question is considered to be out of syllabus question in 2024 exam. Okay, so you can skip if you are only preparing for KCET 2024 exam, but if you are preparing for any other competitive exam, for example NEET or JEE mains, then this question, this part is there in the syllabus, so don't skip it if you are preparing for any other competitive exam. Okay, now let's look into this. Now beta is given by lambda d by d. So beta, we can say beta is proportional to the lambda, right? Because this the setup is unchanged, so d by d is constant in this case. So for electron beta 1, okay, is and divided by beta 2, that is for proton, we can say this is equals to lambda of electron divided by lambda of proton. Simple as that. Okay, this is the basic principle of ratio, right? Basic principle of ratio. Let me write it here only. Beta 1 divided by beta 2 equals to lambda electron divided by lambda proton, right? Now let us recall the de Broglie's principle. This is a mixed concept question. It is a hard question, so it will be of the level of NEET exam. So if you are preparing for NEET exam, this is a very good starting point. Now we know that the wavelength is given by h by p, right? H by p. P means mass into velocity, right? The speed is same in both cases. It is mentioned that speed for proton and electron are same, so V is same in both cases. Only difference that is here is, if you know that H is a constant, Planck's constant, okay, mp by V. So only difference is this mass. Only thing that is differentiating these two wavelengths, this is this mass. Now what we can say about this mass? More mass, wavelength is less. Okay, so for electron wavelength will be more, for proton wavelength will be less. So we can say lambda is greater than lambda electron is greater than lambda p. So this is greater, this is less. So we can say this ratio is actually greater than 1, or we can say beta 1 is greater than beta 2. So correct option is this option D. Okay, but this question is deleted because the initial formula that you need, that fringe width is equals to lambda d by d, this formula is deleted from your PU board syllabus, so no longer there in your PU board syllabus, but this formula is still there. So if you are wondering which part you need to study, you still need to remember this formula. This formula is deleted. That's why this question is considered out of syllabus. Okay, now let's look into the next problem. Next problem is very simple problem. Okay, light of energy E falls normally on a metal of work function E by 3. the kinetic energy of the photoelectric electrons are. We know that energy of electron, energy of photoelectron is given by kinetic energy of the electron, kinetic energy of electron plus the work function. Work function I am writing it here as E0. Okay, that is the minimum energy required to move the electron. Okay, now the work function is given as E by 3. Okay, so and you are asked to find the kinetic energy. So electron, photon has energy E, kinetic energy we don't know, and work function is given E by 3. So from there we can easily calculate K is equals to E minus E by 3. Okay, now one line answer, 2 by 3 into E. This is the energy of the photoelectrons. So the correct answer is option B. Okay, any doubt? If you have any doubt in any question, don't forget to mention that in the comment below. Now next question number 3, same concept, similar concept, that is photoelectric effect. The photoelectric work function for a photometal is 2.4 electron volt. So E naught is given. Okay, E naught is given 2.4 electron volt, right? And there are some wavelengths are given, and among the 4 wavelengths, the wavelength of light for which photo emission is not possible. So photo emission is not possible in one of this answer. Now I will teach you one mathematical approach, then one logical reasoning approach. Okay, one logical reasoning, because only one option is correct, so you don't need to solve it. If you know the logical reasoning, you can easily answer that. Okay, but first let us look into that in terms of mathematics. So we know that energy of photon is given by h nu, right? H nu, or in other terms, nu can be written as c by lambda. So hc by lambda. In terms of wavelength, it is hc by lambda, right? Now what we have to do, we have to convert it into in terms of wavelength, and then you have to check. Okay, and if this value is greater than 2.4 electron volt, if this value is greater than 2. Electron volt, then photo emission is possible. If it is less than 2.4 electron volt, photo emission is not possible. So what is that value? Hc, you have to remember the value of Hc. So 1242, that is the value of Hc. So you need to remember this value. Okay, in terms of nanometer and electron volt per nanometer, that is the value of Hc. So electron volt, now lambda is given 700. Let's start with the biggest one, 700 nanometer, cancel, and you will see that it will come around 1 point something. Okay, 1 point some value you will get. So 1 point something means it is obviously less than 2.4 electron volt. So it is 2 point less than 2.4 electron volts. Suppose it will be say it will be 1.8. So 1.8 is less than 2.4 electron volt. That means photo emission is not possible for 7 nanometer. If you put any other value, you will get greater than 2.4 electron volt. You can try the next bigger, that is 400. So for 400, 1242 divided by 400, you will get some 3 point something. Okay, 3.0. So 3.0 is greater than 2.4 electron volt. So definitely photo emission is possible. Now in case of photoelectric effect, you should remember that photo emission, when it says photo emission is not possible, always choose the highest given wavelength. If it is given in terms of wavelength, always choose highest wavelength. Okay, and if it is given where photo emission is possible, then you have to choose the lowest given wavelength. Okay, for lowest it will always be possible, for highest it will not be possible. That is the logical answer, logical reasoning. Because there is only one correct answer, so only logical answer for that question should be the highest wavelength. Okay, and for it is possible, in that case only possible answer should be the lowest one. Highest one or the higher one should be less than the required for threshold frequency or threshold work function, right? So you have to remember that. if you have any doubt, any question, this is a logical reasoning question. You don't need to do the mathematics, but in some cases maybe you have to do the mathematics. For that I am giving you the shortcut method, that HC's value is very important when you are writing competitive exam. So in that case you have to use this value 1242. You have to remember that value. Next question 4. In alpha particle scattering experiment, if v is the initial velocity of the particle, then the distance of closest approach is d. If the velocity is doubled, then the distance of closest approach becomes. I will explain this question in a detailed way. So at the distance of closest approach, okay, all the energy of the suppose this is the nucleus at the distance of closest approach. When the alpha particle reaches the closest to the nucleus, at that point what happens? Entire kinetic energy of the proton of the alpha particle converts into potential energy, electric potential energy. Right now, what is the formula for electric potential energy? We know that electric potential energy is given by K. Here both the charges are, suppose one is Zd and another one is electron. Okay, so by d. Now if you see, this should be equals to the kinetic energy, that is half mv square, right? So if you see, everything in this equation is constant except this d, except this v. So we can write v square is proportional to 1 by d. Okay, this much information we need. Okay, kinetic potential energy q1 q2 by r. So q1 is Zd, q2 is E. Okay, 2E in this case. So divided by d is equal to half mv square. So you can easily remember this formula, that for closest approach the velocity is square of the velocity is proportional to the square of the distance. Okay, now we will use this formula. So we can write v1 square by v2 square is equals to, it will be reversed, d2 by d1, because inversely proportional. So inversely proportional means when it is v1, d1 will be down, and when it is v2, it will be opposite side, right? This is the meaning of inversely proportional. This is the very basic mathematics. You have studied that in your lower grade, so you have to apply that. You cannot use all the higher more time taking method when you are solving for competitive exam. Now v1 is given v, okay, v2 is given, velocity is doubled, so v2 is v square, v2 is 2v, v2 is 2v square. Okay, and d2 we don't know, d is d. Okay, so first case for v it was d, for 2v how much is d2, that is we are trying to calculate. So now let's calculate it. V square by 4v square. Now cross multiply into d equals to d2. So d2 is equals to this v square cancels, it will be d by 4. So d2 is d by 4. So correct option is option D. Okay, any doubt, any question, don't forget to mention that in the comment. Next question, the ratio of area of first excited state to the ground state of orbit of hydrogen atom is. Now we know that for hydrogen atom, the radius of any excited state is proportional to the quantum number, right? Radius of any excited state is proportional to the quantum number. For ground state, quantum number is 1, right? And first excited state, say R1, we can write this as n0 square by n1 square, right? Now n0 is 1, n1 is 2, so it is 2 square, this is 1 by 4, right? Now what is the area? Area A0 by A1. Now let us find the area. So area is, for obviously according to the Bohr, the radius, the orbits are circular in nature. Okay, so the radius was r0. So what is the area for a circle? Yes, pi r square. For in this case, pi r0 square, and in this case, pi r1 square. So pi cancels, and you can put r0 by r1 whole square. Now r0 by r1 is 1 by 4 whole square, that is 1 by 16. Now which one is first? First excited state to the ground state. So that is, you want to find A1 by A0. We have calculated A0 by A1, but in the question it says first first excited state first, so it will be 16 by 1. You have to be careful. Even if you have calculated and done the calculation correctly, you have to read the question once time more, so that you are sure you are writing the answers correctly. 16:1. So correct answer is option D. Okay, 16:1. Now let's move into the next question. Question number 6. The ratio of volume of aluminium 27 nucleus to its surface area, given its R0 is given that. So what you have to do, R0 is given. Now we know that radius of any nucleus is given by R0 times a to the power 1/3. Okay, so we will use that formula, okay, and find the radius for aluminium nucleus. So aluminium has a 27 to the power 1/3, that is 3r0. Okay, now so we have calculated the r. Now we know that volume. What is volume? Volume is 4/3 pi r cube. This is a spherical size, right? All the nucleuses are spherical in size. So volume is 4/3 pi r cube, and area is given by 4 pi r square. So if you find the ratio volume by area, just a second, it will be volume by area can be calculated as 4/3 pi r cube divided by 4 pi r square. So pi cancels, this 4 will cancel, this 1/3 will be there, don't mess it up, this 1/3 will be remain like this, and r square, 1 r square will cancel, it will only be left with r. So 1/3 r, right? So what is 1/3 r? You can put the value of 1/3 r, 1/3 into 3r0. So this 3 cancels, so only left with r0. What is r0? R0 is 1.2 into 10 to the power of minus 15, okay, meter. So this part, up to this part, this is common for all spherical surfaces, 1/3 r. Remember that volume is to area is always 1/3 r. Okay, and if you remember this, you don't need to do this, but if you don't remember in the exam, then you can just calculate it. Okay, otherwise the data are given such that you are actually getting same answer as the question information. Okay, so this is the answer. Okay, next question, question number 7. Consider the nuclear fission reaction. Nuclear fission reaction was given, and energies are given, assuming that the kinetic energy is carried away by the fast neutrons only. So only these electrons, fast neutrons, are carrying the excess kinetic energy. Okay, this is a slow neutron. This almost has zero kinetic energy. So when this is colliding with this uranium, this reaction is happening, and they are taking away all the kinetic energies, right? So, and what is mentioned that the initial initial energy of the uranium is 18 MeV, final energy of barium is 1200, and that is for krypton is 780 MeV. Respectively, the average kinetic energy carried away by each first neutron is. So first of all, let us find the difference in energy. What is the initial energy? Initial energy is 1800 MeV, right? What is the final energy? Final energy for beryllium is 1200, and For KR it is 780. So it is 1980. So what is the difference? The difference is you have to find that difference in energy gap. Okay, that is 180. Now this 180 MeV is the energy gap that should be taken away by this fast moving neutrons. Now how many neutrons are there? If you see, there are 3 neutrons. Now then if they are taking equal amount, then what will be the energy of each of the neutrons? So for each of the neutrons it will be 180 divided by total number of neutrons, that is 60 MeV. Okay, so the answer is option D. Let's move on to the next question. Okay, the natural logarithm of activity R of a radioactive sample varies with the time t as shown. At t equals to 0, there are n naught undecayed nuclei, then n naught is equals to, take E square is equal to 7.5. So before going into this problem, you can skip this. This is out of syllabus question. This is no longer in your KCET syllabus, but this is a very good problem for NEET and JEE mains. So I am going to solve it quickly. We know that rate of reaction is given by R naught e to the power minus lambda t. What else we know? We know that R naught is equal to lambda n naught. Okay, these two things we know. Also, where this R is coming from, you should know that R is basically dN by dt. Okay, so those who are interested in this, you can search what is N. I am also giving you the N equals to N naught e to the power minus lambda t. Those who are interested in this, they can Google it, they can search it, they can read about it, and mention in the comment below what you have understood. Okay, now what is given is, it is given ln R. Okay, so remember that ln R is given, not R. So at t equals to 0, at t equals to 0, when you put t equals to 0 here, then your this term becomes 1, right? E to the power 0, e to the power 0, any number to the power 0 is 1. So at t equals to 0, okay, and it is given that at t equals to 0, that value is equals to 2. Okay, that value is equals to 2. Now what we have to do? We have to find the value of R0 from this given information. So R0 is basically, if it is, you have done in log series also, if log A equals to X, then A equals to 10 to the power X, right? You remember that? Log A equals to X. Then we can write A equals to 10 to the power of X. Same thing, except in ln, it instead of 10, it becomes E. So it will be E to the power 2. So now E square value is given 7.5. So R0 is 7.5. So what we have calculated? We have calculated R0 value is 7.5. Okay. These things we need to use in our next part. What else is given in this? Look into the diagram carefully. If you look into the diagram carefully, you will see that at this point, when your ln R becoming a half at some time t equals to this, right? So we can write here ln R, okay, at that time is equals to ln R0 by 2, right? Now what we can do from this is, we can calculate the value of lambda t from this equation, right? Now what we can do? We can write this as R by R naught equals to e to the power minus lambda t, right? We can use this as R by R naught equals to e to the power minus lambda t. Now take the ln on both sides. If you take the ln on both sides, we can write ln of same rule as log. So division means it will be subtraction, right? Ln R minus ln R0 equals to, now in case of log, it is 10 to the power, but here it is e to the power, so it will become minus lambda t. So just imagine if there was a 10 to the power x. 10 to the power x means if you take log, that becomes only x. If you take ln for e to the power, that becomes only the power, right? Now multiply with negative, and if you let me use this space, you will get lambda t equals to ln r0. You are multiplying with negative, so r0 will come first and ln r will come second, right? Now you will have this information at t equals to 10 times 10 to the power 3. When t is 10 times 10 to the power 3, ln r becomes 1, whereas ln r0 you have already calculated, ln r0 is 2. So lambda times 10 into 10 to the power 3. This is very important. You have to take this multiplication factor, equals to ln r0 was 2, ln r was 1. So it will be lambda. Now if you multiply 10 into 10 to the power 3, it will become 10 to the power of 4, equals to 2 minus 1, that is 1. So you can calculate this lambda equals to 10 to the power of minus 4. So lambda value is calculated 10 to the power of minus 4. Now you have to use this value to calculate the value of n0. Okay, so what you have to do, you have to use this relation to solve it. So now r0 is 7.5. okay, lambda value is 10 to the power of minus 4, n0 we are trying to find. So n0 will be equals to 7.5 times 10 to the power of 4, minus 4 comes here, and it will become 7500. Okay, so the correct 75,000. okay, so the correct answer is this. Okay, but this question is out of syllabus. If you are not interested, you can skip this part. Let's move on to the question number 9. Depletion region in an unbiased semiconductor diode is a region consisting of. So in depletion region of unbiased diode, both holes and electrons combine each other. There is no longer any free electrons, there are no longer any holes exist, so both are cease to exist. There is a conception that holes are and electrons still exist. No, they recombine and there is no longer any free charges exist. So you cannot say free charges are existing there. So neither free electrons nor holes, both does not exist. So correct option is option B. Okay, the upper level of valence band and lower level of conduction band overlap in the case of, so we have seen the band diagram, conduction band, valence band, conduction band, and they overlap only in case of conductors or metals, right? For metals or conductors they overlap. For semiconductor they does not overlap. Only at higher temperature they overlap. For insulator they never overlap. So silicon is a semiconductor, normal temperature they do not overlap. Okay, copper is a metal, so definitely it overlaps. Carbon is a non-metal, does not overlap. Germanium also a semiconductor, it does not overlap in normal case. So only correct option is option B, copper. Now this is related to Zener diode. This is also out of syllabus. You can skip that question if you are not interested. Let me solve it quickly. So this is RS. Okay, this is VO, and one more information that should have been provided in this question, that VO is greater than VZ. Okay, otherwise this question has no answer. Okay, now what is mentioned here? VO is given here. Now suppose some current is passing through this. Okay, and the voltage drop across this IZ is obviously VZ. Okay, because VO is greater than VZ, so the potential drop across the Zener diode is VZ. Now what is the voltage drop across RS? So total voltage across this is VO. Okay, total voltage across this is VO. Okay, so voltage drop across this, total drop is VO, and across this should be then VO minus VZ. Okay, VO minus VZ for voltage drop across RS. Okay, so VRS, we are writing is VRS, it's basically VO minus VZ. So what is IRS? IRS is given by VO minus VZ divided by RS, right? Voltage divided by resistance is the current. V is equal to IR, right? So V divided by V across any resistance divided by its resistance gives the current through it. This is the current. Okay, this is the current. This is the current. We are calling it IRS, right? Now this current is divided into two parts. One part is going in this direction as IL, and another part is going in this direction as IZ. So IZ will be equals to IRS minus IL, right? That is VO minus VZ divided by RS minus IL. So very simple problem. This is the correct answer, but the concept of Zener diode is not in your syllabus anymore, so this question is deleted. Now let's look into the question number 11. A PN junction diode is connected to a battery of EMF 5.7 volt in series with a resistance of 5 kilo ohm. So a PN junction diode, okay, is connected with a 5 kilo ohm resistance in series to a battery of 5.7 volt. Very simple question. You can answer this question by closing your eyes. The barrier potential is 7 volts. So barrier potential is the forward bias. So P side is connected to the P side and N side is connected to this, so that the current flows in this direction. Okay. And what else? The barrier potential is 0.7 volt. So we know that barrier potential is absorbed by the diode. Whatever rest voltage is, that is allowed to pass through it. So what is the effective voltage? Effective voltage is given by the source voltage minus barrier voltage. This is the actual voltage that is doing the flowing the current. So 5 volt is the effective voltage. So current is V is equal to IR. Okay. So it will be V by R. So 5 volt divided by 5 kilo ohm. So current will be 1 milliampere. Okay, why milliampere? Because there is a kilo here. So don't fall in the trap. Don't make it 1 ampere. It will be 1 milliampere. Okay, this is the only simple trap. Only trap was that if you miss this kilo ohm, then your answer will be 1 ampere. That's it. Otherwise, this is a very simple, straightforward question. Now, this is a very interesting question. A particle of mass 500 gram is at rest. It is free to move along the straight line. The power delivered to the particle varies with the time according to the following graph. Then the momentum of the particle at time t equals to 5 seconds is equals to. So what is the process through which we can solve this question? So the way to solve this question is to find the area under this graph. Okay, you have to calculate the area under this graph. Okay, so if you calculate the area under this graph, then the area under the graph gives the kinetic energy at the end of the cycle. So after that, you can calculate the momentum of the system. So first, let us calculate the area under the graph. So area under the graph is given by, now this is a trapezium. Remember, this is a trapezium. This shape is two sides are parallel. Any two sides are parallel, and one of the line is perpendicular to both of them. Then it is called a trapezium, right? Now what we have to do, we know that for area of a trapezium, half into sum of the parallel sides. So this is 2. This is 8, right? So 2 plus 8. You can use triangle plus rectangle method, but this is the shortcut method. So trapezium is, this is 2. Okay, this is 0 to 2. This is 0 to 8. So half 2 plus 8 times the distance, perpendicular distance between them. So that is 5, right? So this is a trapezium. We can easily calculate the area. Half times 10 times 5. So it will be 5 times 5, 25. Okay, 25 watt second, that is joule. Okay, now this is the energy of the system. This is the energy after this cycle. Whatever the energy of the system, kinetic energy of the system is this. Okay, this is the kinetic energy. Now we know that kinetic energy is given by, there is a relationship of kinetic energy that you need to remember, which is P square by 2m. Here P square is the momentum and small m is the mass, right? So P square by 2m, P square We don't know p square value. We know the m value. M is 500 grams. 500 grams means 0.5 kilograms. So we will use 0.5 kilograms. Okay, and is equals to 25 joules. Okay, very simple problem. Now p square, see, 2 into 0.5 is 1. Okay, so no need to consider anything. That is equal to 25. Okay, 25 into 1 is obviously 25. So p is basically 5. Okay, Newton second. Okay, so understood, this is the correct option, option number C. Next is question number 14. Dimensional formula for activity of a radioactive substance. It only depends on time. So dimensional formula for radioactive activity is T to the power minus 1. Okay, so this is a very borderline out of syllabus question, but somehow they have considered this as in syllabus. You should know that any activity is always dependent on time, so it is only factorized as T to the power minus 1. All the other terms are 0. An athlete runs along a circular track of diameter 80 meter. The distance traveled and the magnitude of the displacement of the athlete when he covers 3/4 of a circle. So what is the meaning of that? So athletic is running in a circular track, but he does not complete the circle. He reaches here and he stops. Now it was asked what is the displacement and time distance traveled. So distance traveled is this. This is the distance traveled. Whereas the displacement is this. This is the displacement. We will solve one by one. Let us first try to find the displacement. So displacement is when the circle is one full circle, then the displacement is 2 pi r, right? So displacement is 2 pi r. The displacement is 2 pi r, but in this case, it is not completed the full circle. It has only completed 3/4 of the circle. So the displacement is given by 2 pi r when the circle is completed, but here it is only 3/4, right? So 3/4 of the circle. Now what is the diameter? Diameter is given 40 centimeter, so diameter is 80 meter. So radius is d by 2, that is 40 meters. Okay, so put the value here, 2 pi into 40 into 3 by 4. So 40 cuts into 10. So 3 to the 6, 60 pi. Now this is sufficient for you to answer this question. Well, you are answering in the hurry. See, only one option has 60 pi. So this is the correct option. You can calculate this 40 root 2, but in this case this is sufficient. Now why is 40 root 2? So radius is 40 meter. So this is 40 meter. This is 40 meter. So what is the this case? This angle is 90 degree. So use Pythagoras theorem, 40 square plus 40 square whole root. That means 40 root 2. Okay, that is the answer for the displacement. Okay. Now, among the given pair of vectors, the resultant of two vectors can never be 3 units. The vectors are, so whenever there are two vectors given A and B, okay, the maximum value of the resultant is A plus B magnitude wise. Okay, and so magnitude of A plus magnitude of B. Suppose two vectors are given A and B. So maximum possible magnitude is A plus B, and minimum possible magnitude is A minus B. Okay, this is the formula you need to remember. Now 3 is given, so we have to check if 3 is possible. For 1 and 2, if you add them, you will get 3. For 2 and 5, if you minus 5 from 2, then you will get 3. For 3 and 6, if you minus 3 from 6, you will get 3. For 4 and 8, no way you can get 3. You can add them, you will get 12. If you subtract them, you will get 4. So for this pair, it is not possible. Next, question number 17. A block of certain mass is placed on a rough inclined plane. The angle between the plane and the horizontal is 30 degrees. The coefficient of static and kinetic friction between them is 0.5 and 0.6 respectively. The magnitude of the acceleration of the block is. So we have to remember that there is a thing called angle of repose. Angle of repose, that is mu is equals to tan theta. Okay, you can calculate this value. You will see that See, one more logical thinking question. If there is not enough data is given in this question, they have given you some random values, only mu is given and angle is given. That means what they are trying to understand, that you can find this logic, that if the value of mu is actually greater than tan theta, then the object will never move. This is called angle of repose, right? If you remember the concept, angle of repose, if the value of mu is greater than tan theta, then the object will never move. Only if the mu is less than tan theta, then only it will move. That is called angle of repose. So here in this case, object will not move and the answer will be 0. Okay. Now, this is a very simple question. A ceiling is rotating around the fixed axle as shown, direction of angular velocity. So how you can find the direction of angular velocity? You have to use your fingers and hand. Okay, if your fingers pointing towards the direction of rotation, if your fingers pointing in the direction of rotation, then your thumb points the towards the rotation vector. Okay, rotation vector. So in this case, or angular velocity in this case. So in this case, it is rotating inside the page. So inside the page means your thumb is pointing downward. So it is inside the page. That means your thumb is pointing downward. So this axis is given as this axis is given as z axis. So it should be along the negative z axis, that is minus k. Now next question. A body of mass 1 kg is suspended by a weightless string which passes over a pulley of mass 2 kg as shown in the figure. The mass is released from the height of 1.6 meter on the ground. With what velocity does it strike the ground? Now this question was controversial. We will see why it is controversial. First, let us understand and solve the actual intended way how it was supposed to be solved. So the thing is, we know that the energy at this height is given by mgh. M is for this mass, right? mgh. Now if this is mgh, what are all the energies that is being converted into? First of all, it is converted into the kinetic energy when it is reaching the ground, half mv square, right? This is the first part. Second part is this wheel with which it is connected to, it is also rotating. Okay, it is rotating with I omega square, right? This is the rotational kinetic energy. So this thing you have to remember. Now you can put the values of I and omega. Do not use the value of mgh yet. So mv square plus half. I is for circle, it is m r square by 2, or half m r square. Half mv square obviously plus half I is m r square by 2 and omega is v square v by r. So omega square will be v square by r square, right? You remember this formula. Now this r will cancel. So even if you don't know this r, they will cancel each other. So no worries. Now you can put the values. So this half will common. Okay, what is left? M, and take the v square as common. So v square is gone, and here there will be m by 2 left. Okay, this is the values will be left. Now what is m? This m is small one, 1 kg. G is 10, h is 1.6, equals to half. This m is 1 kg. This is 2 kg. So 2 by 1, sorry, 2 by 2. V square we don't know. So if you calculate half times this cancels 1. So 1 plus 1, 2. 2 cancels. This is again 1. So v square. So you can write here v square equals to 10 times 1.6, that is 16. So v equals to 4 meter per second. So correct answer is D. Now here the enough information is not given on this diagram whether this pulley will rotate or not. That is the controversy. Okay, if this pulley does not rotate, then the problem is very easy. Okay, If this pulley does not rotate, this problem is very easy. Only thing you have to do is mgh equals to half m v square. Okay, simple as that. This m will cancel. Okay, and you can write v square equals to 2gh. Okay, or v equals to square root of 2gh. Simple formula, 2 times 10 times 1.6, so it will become 4 root 2 meter per second. Okay, so this option also was correct in this problem. So both options were considered correct. If someone has answered any of these two options, then it is considered as correct answer. Okay, now next, what is the value of acceleration due to gravity at a height equal to half the radius of the earth from its surface? So we know that gravity at any height h is given by g is equal to gravitational acceleration on the earth, surface of the earth, plus h by r whole square. Do not use the reduced formula, you have to use the actual original formula. This is the formula on the chapter gravity. If you have studied it, if you remember it. Now we know that g is 9.8, and let me use 9.8 for now, and 1 plus radius is height is said half of the radius, so it is r by 2 divided by r whole square. So it will be 9.8 divided by, only mathematics is there, r cancels, half is there, whole square. So what is 1 plus half? 1 plus half is 3 by 2. 3 by 2 whole square. So it will become 4 times 9.8 divided by 9. Now this is a trick. This is a shortcut calculation trick without using a calculator. So 9.8 divided by 9. They are not exactly cancelling, but for approximation you can cancel this as 1.1. So 9 the 1, 9 ones are 9, and for simplification 8 you can take as 9 only, and you can find the approximated value. You can write this as 4.4 meter per second square. Okay, so your correct answer is this. Now in the book, in the actual calculation, they have used 10. If you are using 10, that will be a little bit more complicated, but if you are using 9.8, it will be easier because you can easily cancel that. Now move on to the next problem. A very interesting problem. A thick metal wire of density rho and length L is hung from a rigid support. The increase in the length of the wire is due to its own weights. Now in this problem, what is not given? The cross-sectional area of the rod is not given. So what you have to do? You have to assume that cross-sectional area of the rod of the wire is A. Now, what is the volume of a rectangular wire? We know that if the length is L, if the area is A, then the volume is given by L into A, right? Los Angeles or LA, right? Now, what is the mass? Mass is given by volume times density. So V into rho. So mass is LA rho, right? Now, when we are hanging this, there will be a force, right? What will be that force? That force will be given by any hanging object will face the force of mg, right? The force is mg. So what is the value of this force? LA rho g, right? Now apply the formula for Coulomb's, Young's modulus. So Young's modulus is given by longitudinal stress, that is F by A divided by longitudinal strain. Strain is delta L, that is increase in length divided by original length. Okay, this is the formula for Young's modulus. Now you take this on this side and this as division, then what you will get? You will get delta L by L equals to F by A, you can write A, and this Y will come here Y. Okay, or what you can write is that from this simplification, what you can write is delta L equals to F by A. Y was there, and there will be one extra L will come from this L. Now if you insert the values, what was the value of F? F was mg, right? So m was LA rho g, right, times L divided by A times Y, right? So this A will cancel and you will get left with rho g L square divided by Y. If you look into the option, what are all the options? This is the correct option, rho g L square divided by Y. Okay. Now, water flows through a horizontal pipe of varying cross section at a rate of 0.314 meter cube per second. The velocity of water at a point where the radius of the pipe is 10 centimeter. So we know that rate of flow is actually equals to A into V. Okay, and it is constant throughout the motion of the pipe. Okay, does not matter, rate of flow should be always constant. Now area, what is the area here? Radius is given 10 centimeter. Radius is given 10 centimeter or equals to 10 into 10 to the power of minus 2 meters. Okay, I always try to convert is using 10 to the power minus 2 to avoid confusion. That is equals to 10 to the power of minus 1 meters. Now we know that area is given by pi r square for circular cross section, right? So pi is 3.14 times 10 to the power of minus 1 whole square, that is 3.14 times 10 to the power of minus 2. So now put the values here. So V equals to R by A, right? V is equal to R by A. R is given as 0.314 divided by 3.14 times 10 to the power of minus 2. You can take that on top. So it will cancel. It will get 10 to the power of minus 1. So 10 to the power of minus 1 times 10 to the power of 2. That is 10. Okay. So the correct answer is option C in this case. Okay. Let's move on to problem number 23. A solid cube of mass m at the temperature theta 0 is heated at a constant rate. It becomes liquid at a temperature theta 1 and vapor at temperature theta 2. Let S1, S2 be the specific heats in its solid and liquid states respectively. If LF and LV are latent heats of fusion and vaporization respectively, then the minimum heat energy supplied to the cube until it is vaporized is. So what we have to do? We have to find the heat in each step. First step, it was solid at temperature theta 0. So it is converted into solid of temperature theta 1. Then at theta 1, it becomes liquid at temperature theta 1. Then from liquid, it is converted into, first it is brought to a temperature of theta 2. Then from there, it is converted into vapor of temperature theta 2. So this is the here conversion of state is happening. Here only heat is being supplied. So what is the heat supplied in this stage? So this is m, okay, into S1 into final minus initial temperature theta 1 minus theta naught. Okay, this much heat is being supplied. Here how much heat is supplied? M into L F. LF is the liquefaction, right? Next, from here to here, what is how much it is supplied? ms2 final minus initial theta 2 minus theta 1. Okay, and here again m into LV. Now if you add all of them, you will get the total amount of heat is supplied. So the correct option is option C. In option D, it is theta 0 in both cases, so don't get confused. The correct option is option C, where theta 1 minus theta 0 in this case and theta 2 minus theta 1 in this case. Okay. Now this is a very simple question. 1 mole gas of ideal monotype gas is given. So what is the work done? So work done is area under the graph. We know that work done is area under the graph. Here it is the simple triangle. So half base is 3v0 minus v0. Simple problem. You don't need to do as long as I'm doing. I'm just trying to explain. So I am writing it a little bit more. Minus p0. So half base into height. So half 2v0 times 2p0. One of the two cancels. So 2p0 v0. Now let's go to the question number 25. the ratio of molar specific heat of oxygen is. So ratio of molar specific heat of oxygen is given by 7/5. You should remember this. Oxygen is a diatomic gas. For any diatomic gas, the ratio of molar specific heat is given by 7/5, and it is 1.4. Okay, 1.67 is for monoatomic gas and 1.28 for triatomic gas. You should remember these three values. This is for diatomic, this is for monoatomic, this is for triatomic. As you increase the number of atoms present in the molecule, the specific heat decreases. Okay. Now, for a particle executing simple harmonic motion at its mean position, what are all the correct options? Velocity is 0 and acceleration maximum. Remember that at mean position, only thing that is 0, that is acceleration. Acceleration is 0, whereas velocity is maximum. Okay, whereas here at the extreme position, velocity is 0 and acceleration is maximum. Right? So it is said at the mean position. So at the mean position, velocity is maximum and acceleration is 0. So correct option is B. All the other options are incorrect. Now, a motorcyclist moving towards a huge cliff with a speed of 18 km per hour blows a horn towards a source of frequency 325 Hz. The speed of the sound in air is 330 meter per second. The number of beats heard by him is. So this is related to Doppler effect, and very interesting question. Many people were not able to answer this question by thinking how I can solve it. So first of all, you have to remember that when the motorcyclist is going towards the cliff, after reflection from the cliff, the reflected sound coming back will create a Doppler effect with the person riding the bike, and there will be a difference in frequency that leads to the beat. Okay, so we know that frequency heard by the observer is given by actual frequency times velocity of sound divided by velocity of sound minus velocity of observer. Okay, so here velocity of observer is 18 km per second, 8 km per hour, sorry. It will be 18 times 5 by 18 meter per second. It will be 5 meter per second, right? This is the speed of the observer. Now, if you calculate the frequency, the initial frequency was 325, speed of sound was 330 divided by 330 minus 5. So it will be 325 into 330 divided by 325. They will cancel. It will be 330. So this is the final frequency of the sound. So final frequency of the sound is 330. Initial frequency was 325. So they will create a beat, and that beat will be delta F equals to 330 minus 325. That is 5. 5 is the answer. So correct option is option A. Now remember that this portion was in the syllabus for 2024 students when they are the first year. That's why this question was not deleted. But right now this portion is deleted from your syllabus. So if same question comes, you can easily assume this is deleted question, because this is no longer in your new latest first year syllabus, which was revised in 2022. So when the students who are writing this paper, they were at first year, in their syllabus it was still there. So this question was considered to be inside the syllabus. Question number 28. A body has a charge of 3.3 microcoulomb. The number of excess electron. This is very simple. Conservation of charge. Quantization of charge. We know that all charges are quantized by this formula, n into E. Okay. So Q is given as 3.2. Magnitude only matters. Sign does not matter. Excess electrons, it says. So excess electron means obviously it will be negative. So 10 to the power of micro means minus 6. N we do not know. Charge of an electron is 1.6 into 10 to the power of minus 19. Right? So N is equals to 3.2 times 10 to the power of minus 6 divided by 1.6 into 10 to the power of minus 19. So it will cancel. It will become 2. So it is 2 times 10 to the power. This will go up and become 10 to the power plus 10 to the power of 13. So correct answer is option C. Question number 29. A point charge of 10 microcoulomb and another point charge of plus 20 microcoulomb are kept 1 meter apart in free space. The electrostatic force on A due to B is F1 and electrostatic force on B due to A is F2. Then which of the following statement is correct? This is also a very simple trivial question. Just to confuse you, you should remember that whatever the magnitude of charges, it does not matter if this is Q1, this is Q2, whatever force this is exerting on this, the same force it is exerting but in the opposite direction. That is why this will be F1 equals to minus F2. Third law of motion, that is each and every action, each action has an equal and opposite reaction. Okay, so this is the formula for that. Now, a uniform electric field E is equal to 3 into 10 to the power 5 Newton per coulomb is acting along the positive y-axis. The electric flux through the rectangle of area 10 centimeter into 30 centimeter whose plane parallel to the zx plane is given by. So this is also very simple. We know that flux is given by E times A. So E is given as 3 into 10 to the power of 5. Okay, it is along y-axis. It is along y-axis and the plane is perpendicular to it. So all the electric field lines are passing through it. So EA cos theta is not required because they are perpendicular, right? Now, what is the, sorry, they are the normal vector are parallel, right? That's why they don't have any cos theta component here. Now, what is the area? Area is 10 centimeter. 10 centimeter means 10 times 10 to the power of minus 2, and 30 centimeter. 30 centimeter means 30 times 10 to the power of minus 2. Don't forget to add these two factor, very important. So 3 times, so 10 times 30 means 300, right? Times 10 to the power of 5 times 10 to the power of minus 4. Okay, so this becomes 900 times 10, that is 9000. Okay, that is 9 times 10 to the power of 3 volt per meter. So we have already completed the first 30 questions of year 2024 with detailed explanation. If you have any doubt, any questions, don't forget to mention that in the comment below. I'll be back with 31 to 60 in our next video. Thank you for watching.